Hi everybody, welcome to my channel again. This is Oliver. We are starting with chapter 2 today. So it's going to be section 2.1, practice A, and with new chapter, new haircut. So hope you like it. All right, so before we start with section 2.1, let's go over the main concepts of this section 2.1. And the concepts are, we have the concept of whole numbers. Then we have the concept of integers, the concept of rational numbers. Then we have the concept of opposite numbers. We have the concept of absolute value. And then we have conditional statements. Okay, so what are whole numbers? 0, 1, 2, 3, 4, and so on to plus infinity. Okay, those are whole numbers. Integers, negative infinity all the way to -3, -2, -1, 0, 1, 2, 3, plus infinity. Those are integers. Rational numbers, quotient of two integers. So if you pick any two numbers from the list above for integers, let's say -3 and 2, or 5 over 3, or 5, because 5 can be represented as 5 over 1, right? So all those are rational numbers. So rational numbers pretty much can be integers, can be whole numbers, or can be fractions, okay? So you just have to remember that it's just a quotient of two integers. Opposite numbers on a number line, the distance between two, if the distance between two numbers and 0 is the same, then those are opposite numbers, like -5 and 5. Okay. Absolute value. What is absolute value? Absolute value is of a positive or negative number is a positive number. That's what absolute value is. And conditional statements is something like if this, then that. So you have a hypothesis and a conclusion. All right. So let's start with section 2.1. So number 1, graph the numbers on a number line. So we have 0 and -3. So that's 0 right there and -3. Then tell which number is greater. So we know that on a number line, we have 0, and then we have 1, 2, 3 to the right, and then we have the negative numbers to the left of the 0. As you move to the right, the numbers increase. So which one is greater? 0 is greater, right? As you move to the right, the numbers increase. So we can say that 0 is greater than -3. Number 2, let's graph -8. So -8 is right there, and -5 is right there. So we can say that -5 is greater than -8, okay? Because it's to the right of -8. -1 is right there, and -12 is right there. So -1 is greater than -12. Okay. Tell whether the decimal representation of the rational number repeats or terminates 1 over 2. So let's see, 1 divided by 2. 1 divided by 2 doesn't go, so we do 10 divided by 2, but then we have to do the period or 0 point. 10 divided by 2 is 5. So 5 times 2 is 10, no remainders. So 1 over 2, or 1/2, is 0.5. It terminates. It doesn't keep going. So it doesn't go further. So 0.5, we say that it terminates. So number 4 terminates. Number 5, we have 2 divided by 3. 2 divided by 3 doesn't go. So we do 20, and then we do the point or 0 point. 20 divided by 3 is 6. 6 times 3 is 18. Minus 20 minus 18 is 2. We see that it's going to keep going. But then we do 20 divided by 3 is 6 again, then 18 again, and then it's just going to keep repeating. So number 5 repeats. So this one terminates. This one repeats. Number 6, we do again 4 divided by 9. Doesn't go, so we do 40, but then we do 0 point. 4 divided by 9 is 4. 4 times 9 is 36. 40 minus 36 is 4, and then we're just gonna keep going. 40 divided by 9 is 4 again. 4 times 9 is 36, and just gonna keep repeating. So this repeats. Okay. Number 7. Tell whether each number is a whole number, an integer, or a rational number. Then order the numbers. Okay, so we have whole, integer, rational. Okay. All right, 17, yes, it is a whole number because whole numbers start from 0, 1, 2, all the way to plus infinity. 17, yes, it's a whole number. Minus 5, no, it's not a whole number. 0, yes, it is a whole number. Integers, minus infinity all the way to 0, plus infinity. 17, yes. Minus 5, yes. 0, yes. Rational numbers, all 3. Okay. All right. That's number 7. That's tell whether each number is a whole number, integer, or a rational number. Then order the numbers from least to greatest. So if you have on a number line these 3 numbers, so 0, then we have minus 5 is going to be somewhere there, and then minus 17 is going to be all the way there. So least to greatest. So minus 17. Actually, this is plus 17. Sorry, so 17 is going to be somewhere there. It's not a minus, it's a plus 17, right? So we have plus 17, we have minus 5 and 0. So if we order the numbers from least to greatest, then it's minus 5, 0, and 17. Right? Number 8, whole numbers would be 4.5 is not a whole number. Minus 3 is not a whole number. 1/2 is not a whole number. So we don't have or none. Integers, 4.5, no. Minus 3, yes. 1/2, no. And then rational numbers, all 3. 4.5, minus 3, 1/2. And then if we order these from least to greatest, minus 3 is the least. So we know minus 3. Then 1/2 is 0.5. So 0.5 is next. And then 4.5. Okay. Number 9, whole numbers first. Whole numbers. Minus 2.8, no, it's not a whole number. 2/3 is not a whole number. 209, yes, it is a whole number. Okay. Integers, minus 2.8, no, it's not an integer. 2/3, no. 209, yes. Rational numbers, minus 2.8, 2/3, 209, all 3. Okay. And then we have order the numbers from least to greatest. Least, minus 2.8. Minus 2.8 is the smallest one. And then 2/3 is 0.6666, right? So that one is next, 2/3. And then 209. All right. Number 10, evaluate the expression when x equals minus 5. So we do minus, and then instead of x, we do minus 5. So this is minus times minus. So the minus times minus is plus. So this is plus 5. So let's review that. So when you have minus and minus, when you multiply minus and minus, that's plus. If you multiply minus with plus, that's minus. If you multiply plus with minus, that's minus. And obviously when you multiply plus with plus, it's plus. Okay. And number 11, absolute value of x when x is minus 5. So this becomes absolute value of minus 5. And we know that absolute value of negative or positive number is a positive number. So absolute value of minus 5 is 5. Number 12, absolute value of x plus 2. Absolute value of x is minus 5. So absolute value of minus 5 plus 2. We know that absolute value of negative or positive numbers is a positive number. So absolute value of minus 5 is 5. So 5 plus 2 is 7. Okay. Tell whether the statement is always, sometimes, or never true for any non-zero integer x. So 2x is a whole number. Okay, so x is a non-zero integer. Okay, so integers, we know that it's negative infinity all the way to negative 3, negative 2, negative 1, 0, 1, 2, 3, all the way to positive infinity. So non-zero. So it can be, let's say, negative 3, or positive 3, right? So 2x, if x is minus 3, we're going to get minus 6. If x is positive 3, we're going to get plus 6. So 2x is a whole number. Well, 6 is a whole number, but minus 6 is not a whole number. Minus 6 is an integer. So this is sometimes true. So number 13, this would be sometimes. Okay, because sometimes it is a whole number. 6 is whole number, but minus 6, sometimes we get minus 6, which is not a whole number. That's an integer. Okay, because x is a non-zero integer. So that could be minus 3 and 3. All right. Next one, absolute value of minus x is a negative integer. Okay, so let's do minus, and then x is minus 3. And then you can have minus, and then x is 3. We know that absolute value of a negative or a positive number is always a positive number. So this is always positive number. So absolute value of minus x is a negative integer. This is never true, because absolute value of any number, positive or negative, is a positive number. So this is never true. Number 15, x over 3 is a rational number. X is a non-zero integer, so it can be minus 3 over 3 or plus 3 over 3 is a rational number. This is always true. Okay? Because we know that rational numbers just a quotient of two integers. All right. Tell whether the statement is true or false. If it is false, give a counterexample. Number 16, if a number is even, then the number is an integer. So what are even numbers? 2, 4, 6, 8, 10, and so on, right? So if a number is even, then the number is an integer. Yes, that is true. Okay. Number 17, if a number is an integer, what's an integer? So negative, right? Negative 3, negative 2, negative 1, 0, 1, 2, 3, all the way to positive infinite. Okay, that's if a number is an integer, then the number is a whole number. That's not true, because whole numbers start from 0 and go to 1, 2, 3, and positive infinity. So this is false. And then give a counterexample. We can say that any number of these, like minus 3, is an integer, but it is not a whole number. So that's the counterexample. Number 18, profit. A small store's monthly profits for 6 months. You can see July, August, September, October, November, December. Those 6 months of 2004 are shown in the table, and that's the profit. So profit for July is $1,800, August $2,300, and so on. In which month did the store make the greatest profit? So the greatest profit is this one, right? 1,800 is less, 2,000 is less, 800 is less, minus, this is minus. They lost money in November. They lost even more money in December. Okay, so in which month? August. Okay. In which month did the store make the least profit? One of the negatives, right? And which one? This one. Because that's the least profit they made. Actually, they lost the most money there in December. Okay. Number 19, miniature golf. In a miniature golf tournament, the total score is given as the number of strokes above or below par. If you're at even par, your score is 0. The player with the lowest score wins. So lowest score wins. For the players shown, who won the tournament? Okay, the lowest score. So on a number line, remember, we have here 1, 2, 3. Those are positive. 1, 2, 3. To the right, and then to the left are negative. We have -1, -2 we don't have, but -3 and -4 we have. -3, and then -4, right? So the lowest score wins. The lowest score is this one, -4. That's the lowest score. The highest score is this one, 3. So lowest score is -4, or that's George. for the players shown who won the tournament, George. Okay, so George wins because the lowest score wins, so George wins. George wins. Who finished last? This guy here had 3. That's Ben. So Ben finished last. All right, that's all for today. If you'd like to see more videos, please like and subscribe to the channel. See you next time, guys. Thank you. Bye-bye.